Looks like we have another no heat call. The customer set her thermostat to 70 last night and everything seemed to be okay. Apparently at some point during the night it stopped. She woke up this morning and it was 60 degrees in her house. She was not entirely sure whether it was an electric unit or a gas unit, but we'll stop by and take a look at that for her and see if we can figure out what's going on. So the thermostat is on and in heating mode, but nothing's happening. So let's go take a look. First thing we see is our LED lights. We've got one red solid light and a flashing green. If we go back over to our diagram here, we see red light on and flashing green. It says pressure switch open volt. Being their error is stating that the pressure switch was open, and being that this motor was hot to the touch, it had been trying to run. And if you'll notice, this one is one that has a capacitor attached. Most of these are shaded pole motors, but let's check our capacitor very quickly if we can get our probes on there. Alrighty, and we have 312.4 microfarads, which I all but guarantee you is incorrect. So let's take this guy off and see what we're really dealing with. Alright, it's looking like we have a 4 microfarad with a plus or minus 5 variance. So I would say 312 is a little bit above 5%. So let's get our capacitor installed. So we're just going to install a standard oval capacitor. Only real difference is the VAC. This one's a 440 by 370. The other one was a 250 VAC. With capacitors, all that's really telling us is the voltage limit they're allowed to handle, which, being that we're 120 volt furnace, either one of them should be perfectly fine. The only real challenge would be finding a place to mount this guy. So we'll just get it in here. Alright, we've reapplied power. What I'm hearing is a hum, and we're seeing our same light pattern flashing. What we've got is this induction fan is actually jammed, so we're not getting any rotation, even with me trying to assist it. Let's turn it back off. These bearings are so hard to turn, so unfortunately we have a faulty induction fan. So we'll have to call the manufacturer and see about ordering one and replacing it. Alright, have a little more light today. But we have our new induction fan. This is just a leftover gasket, which is the reason I'm wearing my gloves. It's fiberglass. We will put our hose back on for our pressure switch. Alright, where is our, there it is. Much better. out our little motor. .29, or well, 2.28, 0.29, somewhere in that range, so we are good there. I heard the relay click, so our igniter should start glowing. Gives it a few seconds to make sure its igniter warms up. We should hear another click from some gas valve. We have ignition. Give it a few seconds, depending on the circuit board. There'll be a certain amount of wait time before the blower comes on to allow the heat exchanger to heat up, so it's not blowing cold air into the house. I just heard another click. I can feel our blower motor running. It's my scientific test. Do see a little flicker there, but what I'm feeling is a bunch of airflow coming out of right there. So we've got a little bit of air hitting me in the face here that's also cycling back around. But all in all, not too shabby. Got it taken care of, and we'll jump back in the truck. Not a bad first job in the morning. I'm glad that thing showed up when it did. We went from 80 degrees yesterday to right now at a little after 7 a.m. It's 51 degrees. So you gotta love Georgia. They're projecting 30s by early this afternoon. So got her taken care of. Those induced draft fan motors are fairly easy to change out. As you saw, just have a little fiberglass gasket. I do like to wear gloves because it's that long weave fibers, I guess you would call it, but they do tend to get a little itchy. So I do suggest gloves, and try not to breathe in the particulates that come off of it. But basically just line up your holes, put your gasket on there, put it all back together, make sure your pressure switch is hooked up, and you're good to go usually. Those little motors are only in, a percentage of a horsepower, so they are not very strong, and most of them are shaded pole motors, so they don't develop a lot of torque when they start. So it does not take much to jam them up, and once they jam, your pressure switch doesn't go off because you're not inducing a draft, so your furnace will not run. It does add a little layer of mechanical failure possibility. The older furnaces, you don't see them much anymore in the 70% range, or natural draft furnaces. They were relying purely on physics of heating up a combustion product in air to induce a draft naturally through your flue. But that also led to using 30% of your heat produced essentially to go up the flue to cause that draft. So we're much more energy efficient nowadays, but it does add another point of failure. So you will see those little induced draft motors go out from time to time, but all in all, not too bad to change out. Changing it on a 90% furnace is a little different, as everything is plastic, because that combustion product is kind of laced with water, and it is a bit acidic. So they use plastic on those. Our temperature's not high enough to melt the plastic, and it's acidic. So they change as far as our side of it very similarly, just a few bolts, and hook it back up. Instead of metal screwing to metal, you've got plastic bolting down to plastic, and then usually a rubber gasket or some kind of fitting hose clamp like device to clamp back onto our plastic flues. But all in all, she's taken care of, and we'll move on to the next one this morning and see what else we can get into.